Okay, percentage question. You should be thinking to yourself, you see percentages and no time, you should be thinking it's probably going to be reverse the change. So Tommy's given a 30% discount and he pays that much for some seeds. What would it be without a discount? Well, he has just paid £16.10 for 70%, hasn't he? Because it was 100, he's paid 100%, but there was 30% off it. 100 take away 30 would be 70. So that's your starting point. So usually we're working out, 10%, and then getting ourselves to 100%, something like that. So to get from here to here, I have to divide by 7. So 1610 divided by 7, that will be 2, carry the 2, and 3. So £2.30, £2.30 is 10%, so 100% would be £23, yeah? Nice and straightforward. Sometimes it can be hard to spot what to divide by. I think the hardest one I've seen to divide by was when something equaled 112.5%. And to get down to 12.5%, we had to divide by 9 because think of 100%, so you get 50%, but that's not big enough. I'll do it over here. If you've got 100%, okay, I've got two 50s in there, that's fine. And within that, I've got 25 and 25, so it's 4 25s. So if you're trying to work out 25%, you can divide by 4. And within 25%, you've got 12.5. So that means you've got 1, 2, 3, 4, 5, 6, 7, 8 of them within 100%. So if you've got 100 and 12.5%, that means you've got 9. If you divide that by 9, you're going to work out 12.5%. So that divided by 9 would just give you 12.5%. Then you could times it by 2 to get to 25%, then times it by 4 to get to 100%, or just times it by 8. But that was probably the hardest one I've ever seen. But try and think about that, visually thinking of your percentages and as fractions within an amount. This one, your power rules, you should be thinking to yourself, okay, if I times, I'm adding my powers. If I divide, I am taking them away. And if I do a power law, I am multiplying them. That's about it. And also, if I say x to the negative 1, that's the same as 1 over x. If I say 1 over x to the 2, that's the same as x to the negative 2. Okay, so in a nutshell, that is your rules. The thing I always remember is, if you say 2, 3x squared, if I call that cubed and square it, that's going to give you 4 over 9 x to the 6. Because don't forget, you still have to square your numbers as normal, which would be 2 squared and 3 squared. So if you remember that, I think that's a really good one, just to remind you that these numbers don't conform to these rules, they conform to the regular rules where you multiply numbers or you square them, whatever. But your indices follow slightly different rules. To the power, you multiply, you add, divide, subtract. So first thing I would do is my power rule. So multiply then, that's negative 8. And I'm multiplying here, so I'm going to add them. So that's going to be m to the negative 13. And change the sign when I cross the line. And that's you done. That is a combination of your power rule, multiply rule, and your negative rule. Nice and easy. So let's say positive power, that's why you'd have to leave it like that. Okay. And yeah, that's not bad. Obviously 3 marks, 1, 2, and 3. This looks like a very tricky question, but don't forget what I said before. When you're doing the algebraic fractions, it's still the exact same rules you're going to follow as regular fractions. You just happen to have more complicated material. So when you're dividing, you're doing keep, flip, change. You're a KFC, okay? So keep that the same, change that sign, and now flip that. And all of a sudden, it's not looking too bad. If I've got, I can rewrite that though. I'll just to show you, you don't have to write it this way, but that's the same as x plus 2, isn't it? If I square something. So that means I can cancel out, by doing a cross cancel, this and this. Nothing to cross cancel here. And if I multiply, I'm just multiplying the top. So 4x plus 2, and I'm multiplying the bottom, which is now just 5. And that's the same as, you could write that as 4/5 x plus 2. It doesn't matter. You could leave it like this. That's totally fine, or like this. So yeah, that's looks hard, but actually pretty straightforward. So remember, when you're adding or subtracting fractions, you want to make these the same. So if this was an add question, I would have to times this by x plus 2 on the top and bottom in order that I'd have the same denominator, and then put them together. Surds. People tend to hate surds. Quickly with your surd rules, root 4 is 2, root 25 is 5. Remember, those those numbers come in quite a lot. Root 40 is the same as root 4 root 10, which is the same as 2 root 10. Okay, remember that. Root 2 plus root 2 plus root 2 is the same as 3 root 2's. Remember that. And I could say root 10 over 4 is the same as root 10 over root 4. So if you remember those, you're doing pretty well. So let's have a look. First thing, we're going to multiply our bracket out. So don't be confused. Root 10 times root 10, that's just root 100. Take away root 20, and to that I'm going to add on 8 root 5. So just multiply my bracket out. Nice. Then I can simplify that. That's going to be 10. And then here I'm thinking to add them together. If I can get them into root 5s, that would mean I could add them together. So I've got root 4 root 5 plus 8 root 5. So just change that into a root 4. So that means that I've got 2 root 5s and 8 root 5s. So I've got 10 and I've got 6 root 5s. If I've got 8, take away 2. So they look quite complicated, but really, they're not too bad. All you need to do is remember your square numbers, and remember that you can rewrite them as, it's the same way as rewriting 40 as 4 times 4, but you just happen to have a root over them. And they add and subtract the same way that just where the x was. If I've got, if I've got negative 2x and 8x, then I've got 6x. You know what I mean? So they do kind of conform to rules that we know. They just kind of look a little bit weird. So that's our surds. Right, we're nearly at the end of the paper, actually. Is this question 14, 15? Yep, getting there. Okay, drawing a graph. So when you're drawing your quadratics, you should be thinking to yourself, this is my roots. We write this in this function so I can tell what my roots are. So if I was to say that y is x plus 1, x take away 3, well, when is y 0? Y is 0 along here, and for that to be 0, one of these brackets has to be 0. So if any one of those brackets is 0, the whole thing becomes 0. So all you do is flip the sign. And if I've got x as negative 1 plus 1 is 0. That becomes 0. So it means my roots are at negative 1 and 3. Very good. If I multiplied this bracket out, I'd get a positive x squared. So that would mean that I've got a happy face. So it's doing something like this. It's not an upside down one. Yeah. The turning point is always bang in the middle of your roots. So if that's negative 1, just so you can see it clear, negative 1, and that's 3, the number in the middle is going to be at 1. Okay. So 1's bang in the middle. And how would I then possibly find the turning point? I know that x is 1. How would I find y? I just sub it in. So for the turning point, so just put your head now, that's your roots. For the turning point, I'd be saying, okay, well, y is equal to, when x is 1, so it's 1 plus 1, 1 take away 3, so that's 2 times negative 2, so it's going to be negative 4. Okay, so that's 1 negative 4. Very good. And the last one is the intercept. So I know that for that one, x is 0, because I'm on this line here. So for that one, for my intercept, I just put an x is 0. So I'm going to say y is equal to 0 plus 1, 0 take away 3, so that's going to give me 1 and negative 3. Multiply them together for negative 3. So my intercept is at 0, negative 3. So not a bad one to get as a question. There's 3 things to find. You've got your intercept, you've got your turning point, and your roots. So I would do the roots first, and that's just your factorizer. So maybe they would ask you to factorize that. They might give you the trinomial and say, just sketch it. So factorize it, get your roots. The turning point's bang in the middle, and then sub in to get the y value. And your intercept is just when x is equal to 0. So that's when y is 0, that's when x is 0. So you can kind of remember that, can't you? And your turning point, your roots, are your factorized form. They might ask you to draw out complete the square, which is written in with the turning point in mind. We've done that already. But yeah, I think this is a nice question. Just remember that your roots are to do your factorizing, And then this is when x is 0 and y is 0.